Welcome. This is the fourth video clip of the lecture or the course Advanced Java at the University of Applied Sciences in Kiel this summer term 2017. What we'll talk about in this little clip is how to handle source sets, what are source sets of Gradle, and how to set up a project with a multi-project. What that is, we'll come to that later. Okay, I prepared a little project here. You can already see my IntelliJ idea. Let's open this project. What have I done? I've prepared a simple project. I have a simple build Gradle. It just has applied the Java and the IDEA plugin. It has a version, it has a source compatibility, which belongs to the Java plugin. I have 3 repositories and I have 1 dependency for the test. So the project looks like this. We have a main source set, we have a source, main, and test. There, this one is empty, it didn't write any tests yet. So this is just a showcase. I've thought of the scenario that you have an API and an implementation of an API. They are all in a default package. Of course, usually you don't have just a default package, but you have a real package. For simplicity, I left that out. Okay, so I defined an interface, called it API, to give you an imagination, a suggestion what that should be, what that should do. And I've just said, okay, there's a get version method, just returns a string. Then I have an implementation of that version, of that method, it just returns the string version. This implements the API. This could be a basic setup. Okay, now we want to talk about source sets. What are source sets? If you have this sort of setup, you have an API and implementation of this API, the default implementation, for example, and you want to reuse this. Or at first you want to separate those two. You want to separate the declaration from the implementation. What you can do is use a different source set. Source set is something. I open the Gradle tab here. A source set, you already see them here. Gradle tells us which source sets it knows. It knows the main source set. That's the default. Those two are default, main and test. Test is the one for the tests. There's the default for writing unit tests, and it also generates all the tasks belonging to this. So you have classes, for example, which belongs to the source set main, and you have test classes, which is the same task actually, just for the other source set. So if I hover over classes, it says assemble main classes. If I hover over test classes, it says assemble test classes. So this prefix here is actually just the source set. Now what we can do is we can create 2 different source sets for our implementation and for the API. So let's do that. Go to build Gradle, and in between here I will declare source sets. It's very simple. Keyword is source sets, and I open up a Groovy closure here and I put in some new source sets. Let's call one API and let's call the other one impl. And as you can see, I've set up my Gradle settings in Eclipse and IntelliJ, sorry, the way that it imports those automatically. It creates imports automatically, which means we have an API already. You have to save the build file, the build Gradle, and now we have 4 source sets. Even though I only wrote down 2, the main source set and the test source set, they don't go away. So we have 2 more. We have API and we have impl. Okay, if you look at the task build category, for example, we now have API classes, we have classes, and we have impl classes and test classes. So what Gradle does here is simply applying those tasks to all the source sets. Okay, great. Now, if you look at it, if you open it up, we have a I have to set the Gradle plugin the way that it creates the directory structure for me, which means I have this directory structure here, and I now can just move the things where I want them. I refactored. Yes. And just said, okay, maybe it was too quick. Just said that moving this API interface over here, now this API implementation cannot access this anymore. But in just a second we will resolve this. We'll move this one, this implementation, to the implementation source set. But that doesn't resolve the problem. Okay, now what we have to do is tell the source sets that they depend on each other. You see, they cannot resolve, on this one cannot resolve the symbol. I can use the autocomplete feature, and the API from my own source set API doesn't show up. Okay, now what source sets do is they separate sources, which means you separate, or you can structure your code with separation of concerns, but still, if you create a jar, for example, this one here, you have to do a little bit more. You have to do some setups here in the build Gradle that it works. But you could set up the jar the way that all source sets get compiled and built into this one jar. So you have separated your code, but you can deploy it as one application. Okay, but now what do we have to do to make this work again? We have to tell the API implementation source set, this source set in impl, that it depends on the API source set. And we've already seen that we can put dependencies on artifacts. And now one new thing is we can put dependencies also on other source sets. Okay, so what we want to do is we want to set up the source set impl. Okay, so if we use the autocomplete here, we take a look at these configuration files: impl compile class path, impl compile only, impl runtime, impl classes. What we want to do is set up impl compile and define it as source sets .api. That's not in the autocomplete because the autocomplete does not know really the source set here. And I want the output. So this means impl compile, the task impl compile, depends on the source set's API output. So if I compile this one, this API, it compiles. If I compile this API, the things that get compiled there, all the artifacts there, they are dependent for implementation of the impl compile task. And as you can see, it now shows up as not wrong anymore, or not buggy. So this would work. Great. That's the first part. So dependencies can be set up for a single task, so to speak, and tell it. Test compilers is the same thing. For example, it's just the compile dependencies, compile time dependency for the test source path, source set. Sorry, this one is for the impl source set implementation, the API. What I suggest you to do is take a look at the Java plugin documentation of the Gradle. It's docs.gradle.org. The current version is brings you to the last one, shows 3.4.1 right now. And in the user guide you will find all sorts of plugins. The Java plugin is one of the default ones. And section 2 is about source sets. It tells you everything what you need to know. Just told you some stuff, but the interesting stuff is where do I want to go? Dependency management. That's the one I went. So we have compile up here, for example, for every source set. We just saw input compile, we saw test compile. Of course, we also have an API compile here, but we don't need that right now. Okay. What else do we have? We have compile only. That's one of the dependencies that you can declare, where you have just a dependency for compile time, and the dependency will be resolved at runtime automatically. What's a good example? For example, if you write a Java servlet, then you need the servlet API. The servlet API will be there provided by the container, by the Tomcat or whatever container you use. And you don't need to provide those at runtime yourself. So you just set up your class path in a way that it's okay, that it's there for compiling, so that you can compile okay, but you don't need to deliver it in your jar. It will be provided at runtime. That's compile only. And same thing with runtime. If you have a runtime dependency, which you don't need at compile time, you can declare it as runtime. Test compile is the same thing, and archives and default are explained here. So take a look at this documentation and try to find out what the Java plugin does for you. Just lots of useful things. Okay, back to the code. That's the first part, source sets. Now the second part is of this little clip is multi-project setup. We are on a way that we have an API, we have declared our API, and we have an implementation of this API. Now what we can do is, or what you might want to do, imagine this scenario where you want to extract this API, a simple declaration, and make it a single project. So you can have a jar for this project only for the declarations. You can use multiple other projects. And maybe in our one project here, we have one implementation of this API to communicate with another component or with another application. So what we can do is we can set up multiple projects. How do we do this? We take our build gradle and we set up a project. Project. Learning to type, okay. Project, you have to give it a name. Now the convention is that it starts with a colon to separate all the projects and all the tasks. You will see that you can call the tasks in Gradle afterwards. Let's call this project API with, for example, colon API colon compile. That's the way where you put up a colon there. Then we want another project and we call it impl. Okay. Save, refresh. Oh, and now we have an error. We have an error. API cannot be found in root project, source sets, multi-projects. You have to do something else. Right, we set up a project, but Gradle now does not know where to find this project. Now we always have a second Gradle file that we hardly looked at. It's the settings Gradle over here. Okay, so let's look at the settings Gradle. We have to tell Gradle to include those subprojects. So we set up project API and the project impl. Now if we save this, go back and don't need to refresh, it's already was time enough to refresh. Now you see we have 3 projects in our build Gradle. We have the source sets multi-project, the root project, we have an API sub-project, and we have an impl sub-project. Let's open them up real quick, and we have just the tasks in here. We haven't defined anything for them. So we have the default tasks of Gradle. Okay, up here we still have source sets and all the tasks that the IDEA and the Java plugin gave us. Great, now what we want to do? Our root project shall not contain any code anymore. So we take all this away, this one too. copy it and paste it into the API, and then we cut it and paste it into the implementation. Get a warning that the modules are not imported from Gradle anymore. Yes, that's okay. Fine with me. Oh, that's funny. We want it to be version and nothing else. Okay, and what else? We don't need any dependencies in the API. And we don't want this impl compile here anymore. Okay. Oh, we don't want the source sets either. They are leftovers from the last section. Modules are not imported. Yes. That's okay. Now we have subprojects here. We have modules. IntelliJ tells us we have modules here. And they have an API source. Okay. I accidentally sort of copied those. And they were set up for me here. Okay. Oh, I click the refresh button again to get rid of those. We don't need anymore. This one, this one, this one, and this one. We can delete them. Okay. Now that's this part here. We can now take the API Java and refactor it over here. So we can delete this API, this former API source set. We can delete it safely. And we take the implementation and we refactor it and move it to the impl source main Java path. We can remove implementation safely. Oh, we can always remove the source. Okay, great. Let's bring up a terminal. What I've already told you is you can now, oh, it's not default impl, it's impl. You can now call different tasks, Gradle tasks through the subprojects. So first move into subproject impl and call the task classes. Let's see what happens. Oh no, it doesn't work. Ah, why doesn't it work? Ah, that doesn't see, cannot find symbol API, which means again, as in the first step with the source sets, now the second project doesn't see the first project. It doesn't know about this API. And because it doesn't see that, it doesn't know that it's overridden. What do we have to do to fix that? Now this project, if this project compiles, it needs to know that this project has been compiled. Ah, wait a second, we need a compile time dependency. Right. Okay, so for previously we wrote impl compile should depend on something else. Now we have a compile time dependency because we're in our own project and have our own main source set again. Right, source main Java. That's the main source set. We use the default source set. So now we can say that the compile for the main depends on something, and it depends on the project :API. Okay, let's save this. Gradle runs here. IntelliJ already shows us that the API can be found. So let's compile this again. And as you can see, it's found its way through impl classes and the build was successful. Now one last thing. We have all sorts of code that's duplicated here. I don't want my subprojects to be compiled to different source compatibility. It's always the same thing. Gradle has a little helper there too, and the helper is called subprojects. Okay, and what I can do is I can copy all the things that are the same up there. So that's exactly the same. I can delete this here. Makes it much shorter and easier to read. So all my sub-projects are version 1. They all have a Java and IDEA plugin. They all have the source compatibility 1.8 of the Java plugin. They all have the same repositories. One project is empty and another project has dependencies. Let's see what's happened on the Gradle tab in IntelliJ. We still have some tasks for the root project because it still is a Gradle project. It's not a Java project anymore. The API has some source sets. The impl has some source sets. Impl has dependencies in source sets and in main, and it says API main compile. This one doesn't have any dependencies. Actually, it shouldn't have any dependencies. The test, yeah, okay. The test source set obviously has a dependency on the main. I didn't show you before, but it should have been there before also. Well, and that's about it. What I wanted to show you about source sets and multi-projects. Okay, go ahead and play around with projects that you have. You probably should have, or you should have some projects you've written before in a basic Java class, for example, or maybe you can find something on GitHub and play around with Gradle a little bit. Think about compile dependencies, think about runtime dependencies. Take a look at all those documentations. It's very important that you learn how to use documentation for your problems. Jan-Philipp will do a troubleshooting video clip at the end. I already showed you some messages that IntelliJ throws up if something goes wrong when compiling the Gradle stuff. But there's always some things you will do wrong. I can promise. Okay, that's for it right now. Take care, and hopefully you will see the next video, watch the next video, and we'll learn about troubleshooting. Bye bye.